Hello, let's continue our Sudoku adventure with Boxed In by Strosahl. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these white dots on the grid. These are crop key dots. They're consecutive dots specifically. So what that means is digits separated by a white dot must be consecutive. So if this was a 2, this could be 1, because 2 and 1 are consecutive, or this could be 3, because 3 and 2 are consecutive. Can't do 2, 4, because those are not consecutive digits. So order doesn't matter, just the fact that they're consecutive. Now, not all the white dots are necessarily given, meaning if in our solution we discover that this is a 2 and this is a 3, Strosahl could have given us a white dot there, but he wasn't nice enough to. And that's fine. He hasn't given us all of them necessarily. And the word necessarily there is doing heavy lifting, because some people will say, if you say not all the white dots are given, then that guarantees there's somewhere on the grid where there is something consecutive without a white dot, which we don't want you to have a mental load of that. That's not needed. All right. And we have these killer cages in the grid. That's these cells surrounded by dotted lines. First of all, digits can't repeat within a killer cage. So normally Sudoku will let you put a 2 here and a 2 here, but that is not allowed within a killer cage. And additionally, the digits inside the killer cage sum to the value on the top left. So these 3 sum to 12. So we could do, say, 2, 4, 6. That would sum to 12. That would be fine. What we can't do is 5, 5, 2, because that repeats the 5. So even though the sum works, we're not allowed to repeat. All right. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right. So I'm noticing we have all 3 cell cages. So it would be a good idea to think about 3 cell cages and what some of the consequences would be. 3 cell cages are so common in Sudoku that I basically have it internalized. But let me tell you how you can think about this if you were to try to discover it yourself. And that does help you internalize it. So let's just pick any old 3 cell cage. Because digits can't repeat, it doesn't really matter which one we pick. So we're going to ignore the sum for a second, and we're just going to say, okay, what would be the minimum sum? Well, I can't repeat digits, so I can't do like 1, 1, 1 to get 3. I'm going to have to do different digits, and the 3 smallest digits are 1, 2, 3. So my minimum sum possible is 6. What's my maximum sum? Well, that would be 4, 5, 6. That would be 15. Now, you'll notice there's only one way to add to 6 and only one way to add to 15. And so, what you'll discover, which if you think about it, it makes a whole lot of sense. The closer you are to the extreme minimum or maximum sum for a cage size, the fewer options you have to fill it. And actually, it's not just, say, the 6 that has the fewest options, that has only one option. The 7 also only has one option. One way to think about that is the 3 in the cage is the only digit that can increase by 1 and preserve non-repeat. Like if we tried to increase the 2 by 1, we'd have 2 3s. If we tried to increase the 1 by 1, we'd have 2 2s. So the only way to get to 7 is to increase the 3. Now, to get from 7 to 8, you actually have 2 options. You can increase the 2 to a 3, or you can increase the 4 to a 5. And so there are 2 options to add to 8. To add to 9, there are actually 3 options. Unfortunately, 2 doesn't repeat again. And then working backwards from 15, 14 also has only one option, and 13 has 2 options, and then 12 has 3 options. It's symmetric from both ends in terms of number of options. So with that said, what we want to do is we want to look for the extremes. Like what's my smallest and largest cage? And I see we have a 14 cage here. And now we know already from what we thought about that even though we don't know what it is quite yet, we know very well how to discover that 14 has only one way to add to it and how to add to it. And so if we start with 4, 5, 6, that's 15. We have to subtract 1 from it. The only way to add to 14 is going to be 3, 5, 6 without repeating a digit. All right. Now I'm wondering how that affects this 9 cage here. So 9 cages have 3 ways to add to them. If we do the 2 smallest digits, 1, 2, that's a 3. That adds to 3. So we could do 1, 2, 6. We could also keep the 1, but do 1, 3, and that would let us do 1, 3, 5. Now, keeping the 1 with a 4, that doesn't work because we'd have to do 1, 4, 4, and that would repeat the 4. So that's it for 1s. But we could also start with 2, and the bare minimum is 2, 3, 4 if we don't use a 1, and that adds to 9 as well. So we can do 1, 2, 6, 1, 1, 3, 5, or 2, 3, 4. And the note that we have here from this at the moment is that we can't use more than one digit from the set of 3, 5, 6. Which doesn't actually seem very restrictive to me. Okay. There's also kind of a relationship between these two cells, which may or may not be useful, but I figured I'd talk about it. So we know that these 3 cells add to 9. We know that these add to 14. And we know that these, this is the key, these add to 21. Because we know that a box has 1 through 6 ones each, and that adds to 21. So we can actually know what this sum is. Because this sum is 21 minus 9, which is 12. So if these add to 12 and these add to 14, we know that there's an exact relationship between these two, meaning that this is 2 smaller than this. Right? Whatever this is, it causes these 2 digits to get to 14. Whatever this is, it causes these 2 digits to get to 12. So this has to be exactly 2 smaller, meaning it's either a 1, or it's a 3, or it's a 4. Now we can then cross-reference this white dot here. The 1 is not possible because this can't be 2. So 1 is gone, which means 3 is gone here. And then the 3 is not possible because this can't be 2 or 4. So it's not 3, meaning that's not 5, and that leaves just 4 and 6. And now 4 can be next to 3 or 5. So that's a 3, 5 pair. And that leaves 1, 2, 6, which actually does add to 9. So we did a good job. All right. That was neat. I actually didn't think that was going to go anywhere, but that might actually be the break-in for this puzzle. All right. So 6 can only be next to 5. Now that we know there, and that gives us 3 and 5 here. Now 5 has to be next to either 4 or 6, just to fill that. But more importantly, we filled a 5 into this 8 cage. So these two need to get us from 5 to 8 in 2 cells. And the only way is 1, 2. So we need 3 more. So that's a 1, 2 pair. Now this can't be 1 or 2 because of the 1, 2 pair, meaning the smallest it can be is 3. So we got to do 3 and then 2 and then 1 in order for that to be consecutive. Next to the 3, we need 2 or 4. This 1 came back, giving us the 2, which resolves the column with a 4. That gives us 2. All right. Now this adds to 10 without 2 or 3. So our bare minimum is 1, 4, 5, and 1, 4, 5 does add to 10. So that's what we have to do. And that places the 4 and the 6 in this box. Now 3 and 6 add to 9, so that has to be 1. 1 has to be next to 2. 1 gives us the 5 and 1. All right, this adds to 12, which means this adds to 10. So this is going to be a 4, 6 pair. The 6 tells us the order, 4 and 6, giving us 1 and 6 here. This has to be a 2. Here we need 1, 3, 5. This is the 3. This is the 5. This is the 1 because of stuff happening here in the columns. We need 4, 5 here. This 5 tells us that's 4 and that's 5. Here we need 3, 6. That's 3, that's 6. How about these two? This is 2, 3. The 2 tells us that's 3 and 2. Here we need 1 and 4. So this 4 tells us that's 1, that's 4. This row finishes with a 5. And then up here we need 3 and 6. That's 3, that's 6. And we're done. All right, cool puzzle, Strosahl. Actually, I didn't think that this would be it, but it actually was, which was really neat. Very nice flow to that intro, and we got to think about all the stuff that's fun to think about with killer cages. All right, well, let me know how you did, and if you enjoyed this one, leave a like, subscribe, and a kind comment below.